Good afternoon, everyone. We will be solving quadratics by factoring today. Okay. Factoring. And we're going to use the X method to factor. Okay, so example number 1, x squared plus 5x equals negative 6. So I'm going to write your steps out here to the side. We're going to make sure that our equation is set equal to 0. And what I mean by that is I want x squared to be positive, and then I have plus 5x, but I don't want this minus 6 on the right side of the equal sign. I actually want to bring that over to be with everything else so that we can factor it. You cannot factor it in this form. So I'm going to add 6. And when I add 6, I'm going to put it behind the 5x here. I can't add those two terms because they're not like terms. 6 doesn't have an x. That's the only time I could add those together, and with x squared as well. It doesn't have an x squared term, so those are not like terms. So we just want to make sure this is in standard form, which means I have the most x's first, then this exponent is a 1, and then this last piece is called our constant. It doesn't have any variables. All right, so once it's set equal to 0, we're going to look for a greatest common factor, something that all of the terms share. Well, this is a 1, and this is a 5, and this is a 6. So I can't divide any of those numbers by the same number other than 1. So we don't have a GCF. So that's finished. Now we're going to factor. So I'm going to find factors of 6 that add to 5. So remember, we want it to multiply to 6 and add to 5. And we also have to keep in mind our integer rules. So I'm going to use 2 times 3, and they're both positive to make positive 6, and they're both positive to add to 5. I couldn't use, so sometimes students will want to use 6 and 1 and say that 1 is negative, and that makes the 5, but nothing about the numbers here have any negatives with them, so I have to use 2 and 3. So I've got x plus 2 and x plus 3. And I still need to remember that this is set equal to 0. That's going to tell me or remind me that I need to set each factor equal to 0 and solve. So by that, I mean I'm going to take x plus 2 and equal it to 0, and I'm going to set x plus 3 equal to 0 so that I can solve. So when I subtract 2 from each side, x equals negative 2. And when I subtract 3, x also equals a negative 3. So you will be getting 2 answers for these problems. And the reason you're getting 2 answers for these problems is because, truthfully, we're working with 2 x's. If this was x to the 3rd, we'd get 3 answers, x to the 4th, 4 answers, and so on. That's actually called the fundamental theorem of algebra. You'll learn more about that in Algebra 2. All right, let's do another problem. So I'm going to shorthand those steps just so that we're repeating that. We're going to make sure that the equation is set equal to 0. So that means I want to move this 12x by adding it to the other side of the equation. And that 12x, the term with x in it, needs to go between x squared and the constant. We want to make sure that this is in standard form. So this becomes x squared plus 12x plus 32 equals 0. So now we'll check for a GCF. So I'm looking at 1, 12, and 32. Since our leading coefficient is 1, we don't have a number that all three numbers have in common. So we don't have a greatest common factor. Even though 12 and 32, we could divide something out of those, but they all have to have in common 1, 2, 3 terms. All right, so we're ready to just go ahead and factor. So I need factors of 32 that add to 12. So some factors of 32 that might add to 12. I think 8 and 4, 8, 9, 10, 11, 12. Yep, that's the one. And since 32 is positive, they're the same sign. Since 12 is positive, they're both positive. X plus 8, x plus 4. Our equation is still set equal to 0, which reminds us that we are going to have to set each factor equal to 0 and solve. So that's our last step. So x plus 8 equals 0, x plus 4 equals 0. I subtract 8, and I subtract 4. So again, you will always get two answers. They may not be two different answers. You could get the same answer twice. That's a possibility. They're not always both going to be negative. That just happened in these couple of examples. Sometimes you'll get positive numbers for your answers, just in case you're thinking about that. All right, let's do a few more. And this is going to be an example with a GCF in it, just so you know. All right, so in the first step, we have to make sure that the equation is set equal to 0. So I'm going to add 7 to both sides, making sure I'm lining it up with its like terms. So I've got 5x squared minus 10x minus 40 equals 0. All right, so now that it's set equal to 0, I'm going to check for that GCF. So I kind of give you a heads up that we are going to have one. So I see 5, 10, and 40. And 5, 10, and 40 can all be divided by 5. So we're going to divide out that greatest common factor. It's going to sit in the front of a set of parentheses. This becomes 1x squared. Negative 10 divided by 5 is negative 2x. Negative 40 divided by 5 is negative 8. This is still set equal to 0. So I'm just going to keep bringing down our greatest common factor, although in our next step, we're just going to factor this trinomial using the x method. So we checked for a GCF. Now we're going to factor that trinomial. So I'll find factors of negative 8 that add to negative 2. So when I set up my factoring, it gives me a couple of hints. So because it's a negative 8, I know I'm going to have a positive and a negative. because it's a negative 2, I know of that pair of numbers, the bigger number is going to be my negative. So 8 is 4 times 2, but I'm going to make 4 my negative, so that 2 minus 4 is how we get that negative 2 on the bottom. So I'm going to bring down that GCF, that 5. It is still part of my work. X plus 2, x minus 4. This is still set equal to 0. So in that last step of our process, you're only setting anything with an x equal to 0 and solving. So I only have 2 factors or 2 places where x is that I can get answers to. X plus 2 equals 0, x minus 4 equals 0. So I get a negative 2 as one of my answers and a positive 4 as another one of my answers. So another way I know that I don't need to do anything with this 5 is if I set that equal to 0, well, that doesn't even make an equation. So that's just another way that you know you don't need to worry about setting that equal to 0. All right? I'm going to do a couple more with you until you feel comfortable. I'll do another one with, yeah. Okay, so I've got, this is going to be another problem with a greatest common factor. Just as a warning, they won't warn you in Delta Math or on the EOC, but I'm just giving you a heads up. Okay, so I need to make sure that my equation is set equal to 0. I always want to keep the x squared term positive. So I'm going to add 4x over, I'm going to subtract 8 over so that I keep this positive. That's very important. So I add 4x underneath negative 4x, and I subtract 8 under negative 24. Make sure you're lining up those like terms. So I've got 2x squared negative 4x plus 4x. Well, that's 0x, so I'm not going to put anything in that spot. Negative 24 minus 8 is going to be negative 32. When you're working with equations, never lose your equal sign. You always want to keep it in your equation, especially when you're moving things around. Negative 4x plus 4x is 0. 8 minus 8 is 0. So we have now set the equation equal to 0. I'm going to rewrite that one more time, a little bit closer to each other. All right, so here is where it's very important to check for your GCF. Check for GCF. 2 and 32 have a common factor that I can divide out. They're both divisible by 2, leaving me with 1x squared minus 32 divided by 2. That's going to give me a negative 16. This is still set equal to 0. Now I'm going to factor just this inside piece. So what we have here is we need to find factors of negative 16, but it's not a trinomial. There's not a term with just an x in the middle. So we want to find terms that multiply to negative 16 but add to 0. Since that negative 4x plus 4x was 0x, that's kind of where I'm getting this from. We are going to find factors that add to 0. So for negative 16, I know that One term is positive and one term is negative. 16 will be 4 times 4. And that 4 minus 4 is how we get 0. This is also called a difference of squares, because x squared is a perfect square, and minus for the difference, and 16 is a perfect square. All right, so I'm going to bring down that GCF. It is still part of what I'm doing. And I'm going to factor x squared minus 16 into x plus 4 and x minus 4. Oops, kind of running out of space there, sorry. My problem is still set equal to 0, which reminds me, anything with an x needs to be set equal to 0 and solved. And what you should be noticing is the pattern that from your factors to your answers, really, we're just kind of switching the signs. But we're switching these signs because we're setting them equal to 0 and doing the opposite operation to get it to the other side of the equal sign. Again, we would not set that GCF equal to 0 and solve because it doesn't have an x. 2 equals 0, well, that's why we just kind of ignore that. Okay, so I'm going to do a difference of squares with you one more time. I'm not sure how many times you've seen that. So this will just be example 5. X squared minus 48 equals 1. We're going to set our problem equal to 0 by subtracting 1 on both sides. X squared minus, that'll become 49, equals 0. There is no greatest common factor because there's nothing in front of x squared, and I only have a negative 49 here. So I'm ready to go ahead into my x method. We need factors of negative 49 that add to 0 since there's not a term in the middle. Because it's negative, we need a positive and a negative term. So we'll use a positive 7 and a negative 7. 7 minus 7 is 0. 7 times negative 7 is negative 49. I'm going to bring down my equal 0, which reminds me, I'll take each of these factors. So they're called factors when they're written in these parentheses. And once we set them equal to 0 and solve, they get a new name. They'll call these zeros. Or solutions, or sometimes they'll call them roots. All right, hopefully this video has been helpful. Have a great day.